Lesson 5.3, Solving Multi-Step Inequalities. Our essential question today is how does solving a multi-step inequality compare to solving a multi-step equation? In Chapter 2, we solved a lot of different kinds of multi-step equations, and today we're going to be solving a lot of different kinds of multi-step inequalities. So the key word in the essential question is the word compare. Compare means how are they similar, how are they different? So make sure that you address both of those questions when you write your summary today. Our first inequality is a two-step. Please remember from in Chapter 2 that the term with the variable in it, I'm going to circle the entire thing, it's negative 2x. And that is not going to be something that we deal with on our first step. It's the 10 that is a little further away and outsider. The 10 is what we need to eliminate first. It's a positive 10, so we need to subtract it. 23 minus 10 is 13. These 10s are gone. And I've got my symbol. So it's greater than or equal to negative 2x. Remember, what starts in inequality stays in inequality. So please do not lose your inequality symbol. Now the second step to get the x by itself would be dividing by negative 2x. Oh, sorry about that. Dividing by negative 2. And if you divide both sides by negative 2, the negative 2's in front of the x cancel out, you get negative 6.5. And you have to remember from lesson 5.2 that dividing by a negative number, in order to keep your inequality true, you have to flip your symbol around. So my solution is now x is greater than or equal to negative 6.5 if I write the variable on the left-hand side. Next example, another two-step inequality. On this one, the married couple would be the x divided by negative 4, the fraction. So we need to eliminate the 11 first by subtracting it. So my result would be x divided by negative 4 is less than or equal to negative 8. And then the second step, I need to multiply by negative 4 on both sides. And I also need to flip my symbol because multiplying or dividing both sides in your action step, multiplying or dividing by a negative number, causes your inequality symbol to flip in order to keep your inequality true. Next example, our favorite kind of problem when we've got a fraction next to the variable. Okay, on this problem, our couple is the negative 4/3 x, so we need to subtract away the 1 first. So 8 is greater than negative 4/3 x. Then we've got two options. We can either do 2 more steps, or we can multiply by the reciprocal. So I'm going to multiply by the reciprocal to cancel out the entire fraction in one step. But if you would prefer, you could split it into 2 steps, where you would be multiplying by the 3 and dividing by the negative 4. Now because I'm multiplying by a negative, I do flip my symbol. And if I multiply straight across with my fractions, I will be able to reduce this to negative 6. So negative 6 is less than x, or x is greater than negative 6. Remember, I prefer to have the variable on the left-hand side. I think it's more common to see if you're taking a multiple choice assessment. You usually will see that they start with the variable x. Even if they don't, it's good to recognize that those are equivalent to each other. Okay, now we're going to move into some problems with parentheses. Hopefully you remember that when we see parentheses in our equation, our first step is to distribute. So if I distribute the 6, I will get 30x minus 18. Multiply both terms by the 6. Now I have a variable on each side, so I'm going to subtract away the smaller variable. So negative 18 is less than 6x, and then divide by 6 on both sides. So negative 3 is less than x, or x is greater than negative 3. On this problem, I did not have to flip my symbol around because I was dividing by 6 as an action step and subtracting 30x. So subtraction never causes you to flip your symbol, and neither does addition. It's just multiplying or dividing by a negative number. More parentheses. This time we have parentheses on both sides. So I need to distribute on both sides. That will give me 2x plus 12 and negative 24 plus 3x. Be really careful with your signs when you're distributing a negative number, like the negative 3. A negative times a positive is a negative, but a negative times a negative is a positive. And negative 3 times negative x, if I put a 1 in front, would be times negative 1x, so it gives you positive 3x. Now I've got a variable on each side. Subtract away the smaller one. And 12 is greater than negative 24 plus x. 3x minus 2x is 1x, but I don't have to write the 1 in front. Now I need to add the 24 to eliminate it. 12 plus 24 is 36, so 36 is greater than x, or x is less than 36, to put the variable on the left-hand side. Our last example, this one's tricky because when you distribute on this problem, I treat that 4 as a negative 4 because it has a subtraction sign in front of it. So that's the same as adding the opposite. So I'm going to distribute it as a negative 4. So the result will be 10x minus 8x minus 20. Now these variables are on the same side. So that means that they can be combined. 10x minus 8x is 2x. And now I have 2 steps left. Add 20 to get 66. And then divide by 2 for the final answer. 33 is less than or equal to x. And if I flip it, x is greater than or equal to 33. Now, there's no reason to flip a symbol on this problem because by action steps, we're just adding 20 and dividing by positive 2. So if you divide by positive 2 or add 20 on both sides, you don't flip your symbol. I'm going to go back for a second to the previous problem because in class I had a couple of students ask about distributing this negative 3 right here. And that is distributing, that's simplifying that expression. That's not an action step where you're multiplying both sides of your inequality by negative 3. So they were questioning whether or not that would matter if you were multiplying only on one side, and that does not affect your symbol at all. You're just simplifying the expression that's written on the right-hand side. It's an action step when you multiply or divide a negative number on both sides of your equation that causes your symbol to flip. You should be able to write your summary now. And here are your homework problems.